Greetings, curious humans. Today, we embark on an exciting journey to the largest planet in our solar system, Jupiter. Join us as we dive into the fascinating world of this gas giant and explore its mesmerizing features, breathtaking moons, and captivating mysteries. Jupiter, with its immense size and vibrant atmosphere, has been a subject of intrigue for centuries. Its iconic swirling clouds and massive storms, like the famous Great Red Spot, captivate our imagination and challenge our understanding of planetary dynamics. But Jupiter is not just about its awe-inspiring storms. This magnificent planet plays a crucial role in shaping our solar system, influencing the orbits of other planets and attracting a multitude of asteroids and comets. Its powerful gravitational pull makes it a true cosmic force. And let's not forget the Galilean moons Io, Europa, Ganymede, and Callisto. These mesmerizing worlds offer unique insights into the possibility of extraterrestrial life. From the volcanic activity on Io to the icy subsurface oceans of Europa, these moons continue to intrigue scientists and spark our curiosity about the potential for life beyond Earth. But there's so much more to explore. In this video, we'll delve into the mysteries of Jupiter's atmosphere, uncover the secrets of its magnetic field, and learn about the exciting missions that have ventured to this giant planet. So, buckle up and get ready for an extraordinary journey to the realm of Jupiter. From its mesmerizing storms to its captivating moons, this is a destination that promises to ignite your imagination and deepen your appreciation for the wonders of our cosmic neighborhood. Jupiter is the largest planet in the solar system and the fifth planet from the Sun. It is a gas giant composed mostly of hydrogen and helium. Jupiter's rapid rotation gives it a slightly flattened shape, and its atmosphere is divided into distinct bands with storms and turbulence. The Great Red Spot, a massive storm, has been observed on Jupiter since 1831. Jupiter has a faint ring system and a powerful magnetosphere. It has 95 known moons, including the 4 largest moons discovered by Galileo Galilei, Io, Europa, Ganymede, and Callisto. Jupiter has been visited by several robotic probes since 1973. The planet was named after the chief deity of ancient Rome. In Germanic mythology, Jupiter is equated to Thor, and the name Thursday may have replaced the Latin name for the day associated with Jupiter. The adjectival forms Jovian and jovial are derived from Jupiter and have different meanings. Jupiter is believed to be the oldest planet in the solar system, forming beyond the snow line where volatile substances could condense into solids. It started as a solid core and gradually accumulated its gaseous atmosphere, reaching a mass 20 times that of Earth. Jupiter's growth created a gap in the solar nebula and took approximately 3 to 4 million years to reach its final mass. According to the Grand Tack hypothesis, Jupiter initially formed at a distance of 3.5 astronomical units from the Sun and migrated inward due to interactions with the gas disk and resonances with Saturn. This migration disrupted the orbits of inner super-Earths, causing destructive collisions. Eventually, Jupiter and Saturn settled into a 3-to-2 resonance and migrated outward, influencing the formation of the inner planets, including Earth. However, there are unresolved issues and alternative models regarding Jupiter's migration and formation location. Recent research suggests that Jupiter may have formed outside the nitrogen and argon snow lines, possibly as far as 40 astronomical units from the Sun, and migrated inward over a 700,000-year period. In this model, Saturn, Uranus, and Neptune also formed farther out and experienced inward migration. Jupiter is a gas giant with a diameter of 142,984 kilometers and a volume 1,321 times that of Earth. Its atmosphere is primarily composed of hydrogen, 76%, and helium, 24%, with trace amounts of other elements and compounds. The interior of Jupiter is denser, consisting of approximately 71% hydrogen, 24% helium, and 5% other elements. The atmospheric proportions of hydrogen and helium reflect the composition of the primordial solar nebula. Jupiter's mass is 318 times that of Earth and 2.5 times that of all other planets combined. It radiates more heat than it receives from the Sun due to internal contraction. The planet has a diffuse core mixed with its mantle and estimated to be 30 to 50% of its radius, containing heavy elements. The upper layers transition from gas to liquid, with a supercritical fluid state of hydrogen. Precipitation of helium and neon occurs in the lower atmosphere. Jupiter's temperature and pressure increase inward, and its diluted core is estimated to have a temperature of 20,000 Kelvin and a pressure of around 4,000 gigapascal. Jupiter's atmosphere is covered with clouds of ammonia crystals, forming bands of different colors known as zones and belts. These clouds are located in the tropopause layer and are composed of ammonia and possibly ammonium hydrosulfide. The cloud layer extends to a depth of 3,000 kilometers below the visible cloud tops. The atmosphere exhibits various storm systems and turbulence, with wind speeds reaching 100 meters per second in jet streams. The Great Red Spot is a persistent anticyclonic storm on Jupiter that has existed since at least 1831 and is larger than Earth. Jupiter's cloud layers consist of multiple decks of ammonia clouds, with a possible layer of water clouds beneath them. The colors in Jupiter's clouds are caused by upwelling compounds that react to sunlight. Lightning and thunderstorms occur, driven by heat rising from the planet's interior. Jupiter's poles contain cyclones and other atmospheric features, similar to the hexagon at Saturn's North Pole. The planet's magnetic field is the strongest of any in the solar system, generated by eddy currents in the metallic hydrogen core. Jupiter's magnetosphere interacts with the solar wind, forming a bow shock and magnetosheath. The four largest moons of Jupiter orbit within its magnetosphere. The moon Io's volcanic activity generates a gas torus that interacts with Jupiter's magnetosphere, producing plasma sheets and strong radio emissions. Jupiter has a faint planetary ring system consisting of an inner halo, a main ring, and an outer gossamer ring. Unlike Saturn's rings, Jupiter's rings are composed of dust rather than ice. The main ring is believed to be made up of material ejected from the moons Adrastea and Métis, while the gossamer ring is thought to originate from the moons Thebe and Amalthea. There is also evidence of a fourth ring composed of debris from the moon Amalthea. Jupiter's average distance from the Sun is 778 million kilometers, and it completes an orbit every 11.86 years. Its orbital plane is inclined at 1.30 degrees compared to Earth. Jupiter's axial tilt is small, resulting in insignificant seasonal variations. The planet rotates on its axis at a fast rate, completing a rotation in less than 10 hours. Its rapid rotation creates an equatorial bulge, making it an oblate spheroid. Jupiter's equatorial diameter is longer than its polar diameter by 9,276 kilometers. 3 reference systems are used to track Jupiter's rotation, with different periods depending on the latitude of the observed features. Jupiter is typically the fourth brightest object in the sky, after the Sun, Moon, and Venus. Its brightness varies depending on its position with respect to Earth, ranging from as bright as -2.94 to -1.66 in visual magnitude. Jupiter's angular diameter also varies from 50.1 to 30.5 arcseconds. It undergoes retrograde motion for about 121 days during opposition and appears nearly fully illuminated when viewed from Earth. Jupiter's 4 largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610. Giovanni Cassini made significant observations of Jupiter's atmosphere in the 1660s, including spots and colorful bands, its oblate shape, and its differential rotation. The Great Red Spot, a prominent feature of Jupiter, was first observed and documented in the 17th and 18th centuries. The timing discrepancy in the eclipses of Jupiter's moons led to the estimation of the speed of light by O. Romer. Additional moons were discovered, including Amalthea in 1892, and further observations and discoveries were made in the 20th century. On July 14, 2022, NASA released images of Jupiter and related areas taken by the James Webb Space Telescope, JWST, providing new insights, including infrared views. In 1955, Bernard Burke and Kenneth Franklin discovered that Jupiter emits radio waves at a frequency of 22.2 MHz, which helped determine its rotation rate. 3 forms of radio signals transmitted from Jupiter have been identified: decametric radio bursts, decimetric radio emission, and thermal radiation from the planet's atmosphere. Jupiter has been explored by automated spacecraft since 1973, starting with the Pioneer 10 mission, which provided close-up images of Jupiter's atmosphere and moons. The Voyager missions in the late 1970s provided further understanding of Jupiter's moons, rings, and the Great Red Spot. The Ulysses Solar Probe, Cassini Probe, on its way to Saturn, and New Horizons Probe, on its way to Pluto, also flew by Jupiter, capturing data on its magnetosphere, moons, and volcanic activity on Io. These missions have contributed to our knowledge of Jupiter and its various phenomena. The Galileo mission, which reached Jupiter on December 7, 1995, became the first spacecraft to orbit the planet. It conducted multiple flybys of the Galilean moons and Amalthea, and witnessed the impact of Comet Shoemaker-Levy 9 with Jupiter in 1994. Despite some technical difficulties, the mission provided valuable data about Jupiter's atmosphere, including the discovery that hydrogen makes up to 90% of it. The Galileo orbiter was deliberately steered into Jupiter's atmosphere on September 21, 2003, to avoid contamination of Jupiter's moon Europa. NASA's Juno mission arrived at Jupiter on July 4, 2016, with the goal of studying the planet in detail from a polar orbit. Juno completed 12 orbits before its initial mission ended in July 2018, but its operations were extended multiple times, with the latest extension scheduled until September 2025. The spacecraft has provided valuable insights into Jupiter's atmosphere and magnetosphere, including capturing images of Jupiter's North Pole. Several missions to study Jupiter's larger icy moons have been proposed. NASA's canceled GMA, Jupiter Icy Moons Orbiter, was intended to explore these moons, and a joint NASA/ESA mission called EJSM/Laplace was planned but later abandoned. Instead, the European Space Agency's Jupiter Icy Moon Explorer, JUICE, was launched in April 2023, and NASA's Europa Clipper mission is scheduled for launch in 2024. Other proposed missions include the Chinese National Space Administration's Tianwen-4 mission, which aims to send an orbiter to the Jovian system, and CNSA's Interstellar Express and NASA's Interstellar Probe, which would use Jupiter's gravity to reach the edges of the heliosphere. These missions hold the potential for further exploration and understanding of Jupiter and its moons. Jupiter has a total of 95 known natural satellites, with the possibility of more being discovered in the future due to advancements in instrumentation. Among these satellites, 79 have a diameter of less than 10 kilometers. The 4 largest moons of Jupiter, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. These moons were discovered by Galileo and are easily visible from Earth with binoculars on a clear night. The orbits of Io, Europa, and Ganymede form a pattern called a Laplace resonance, where their gravitational interactions cause their orbits to become elliptical. Jupiter's tidal forces work to circularize their orbits. The eccentricity of their orbits leads to regular flexing and heating of the moon's interiors, resulting in volcanic activity on Io and geological changes on Europa. Jupiter's moons are classified into different groups based on their orbital elements, and they can be divided into irregular moons, which have nearly circular orbits near Jupiter's equator, and irregular moons, which have more varied orbits and are likely captured asteroids or fragments of captured asteroids. Jupiter's strong gravitational influence has played a significant role in shaping the solar system. The orbits of the other planets, with the exception of Mercury, are closer to Jupiter's orbital plane than the Sun's equatorial plane. Jupiter is also associated with the Trojan asteroids, which are asteroids that settle around the Lagrangian points preceding and following Jupiter in its orbit. These asteroids are divided into Greek and Trojan camps. Jupiter's immense gravity well and its location near the inner solar system make it a significant factor in the dynamics of comets and asteroids. It is often referred to as the solar system's vacuum cleaner because it attracts and influences numerous objects. Jupiter experiences more impacts, such as comets, than any other planet, and it is believed to have a role in either shielding or redirecting comets towards Earth. The collision of Comet Shoemaker-Levy 9 with Jupiter in 1994 was a notable event that was observed and studied extensively. There have been historical records and drawings suggesting potential impact observations on Jupiter between 1664 and 1839, and further investigation has identified a dark surface feature discovered by Giovanni Cassini in 1690 as a possible impact scar. Thank you for joining us on this fascinating exploration of Jupiter, the largest planet in our solar system. We hope you've enjoyed diving into the intriguing world of this gas giant and its mesmerizing moons. From its majestic swirling clouds to its colossal storms, Jupiter has continually captivated scientists and astronomers throughout history. Its immense size and gravitational influence have shaped our solar system and left us in awe of its sheer power. We encourage you to stay curious and continue your journey of cosmic exploration. Don't forget to subscribe to our channel to stay updated on the latest discoveries, mission updates, and insights into the wonders of space. Remember, the universe is an endless source of knowledge and wonder. Keep gazing at the stars, keep exploring, and keep seeking answers to the mysteries that lie beyond our planet. Thank you for watching, and we look forward to embarking on future cosmic adventures together. This is Scibot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.